When you think of concrete, what comes to mind? Something heavy, right? Solid. Something that sinks like a rock. Well, what if I told you concrete can actually float?
Yeah, I know. It sounds completely impossible. So, how does it work? How can this stuff, the very definition of sinking, actually float on water?
Well, it turns out there are two totally brilliant ways to solve this puzzle. You've got the scientist's solution on one hand, and then you've got the engineer's solution on the other. All right, let's dive into path number one, the material solution. This is all about changing the concrete itself to make it lighter than water.
Okay, so your standard everyday concrete has a density of about 2,400 kilograms per cubic meter. That's almost 2.5 times heavier than water. So yeah, a block of this stuff, it's going straight to the bottom, no question.
Water is our magic number here, right? It sits at 1,000 kilograms per cubic meter. The rule is simple. If you want to float, you've got to be lighter than that.
And that's exactly what scientists did. They got clever. They started mixing in things like tiny air bubbles or super light stuff like volcanic pumice. And just like that, you get a lightweight concrete that's actually less dense than water. It's literally born to float.
Okay, that's cool, but what if you have to use that old school heavy concrete? Well, that's where the engineers come in with path number two. It's not about the material, it's all about the shape. This whole idea hinges on a classic piece of physics, Archimedes' principle. You've seen this in action with giant steel ships, right? The steel itself is obviously super dense, but because the ship is shaped like a massive hollow bowl, it pushes aside a huge amount of water, and that water pushes back up with enough force to keep the entire thing afloat. And if you want the most incredible, mind-blowing example of this in history, look no further than the D-Day landings back in 1944. The plan was just audacious. They decided to build these enormous, hollow concrete boxes, called caissons, in Britain. Then, they'd float them across the English Channel and sink them in place off the coast of Normandy to create two brand new artificial harbors out of thin air. Just incredible. And did it work? You bet it did. These floating concrete harbors became the absolute lifeline for the invasion. We're talking over 2.5 million soldiers, 500,000 vehicles, and 4 million tons of supplies. It played a critical role in securing victory in Europe. And you know that amazing feat of wartime engineering didn't just fade into history. It left behind a powerful modern legacy. Because of that principle, today we can build some truly amazing things. We're talking about the world's longest floating bridges, like the SR 520 bridge in Washington. Or think about those massive offshore platforms for oil and gas sitting out in the ocean. All of them are made possible by this idea of shaping heavy concrete to command the water. So there you have it, two different paths to solve one amazing paradox. One path changes the concrete itself, the other masterfully changes its shape. It just goes to show you how a little bit of science and a whole lot of clever engineering can completely redefine what we thought was possible.